Good morning, ladies and gentlemen. Welcome back. So today's lesson is on reviewing of quadratics, and we're going to fly through some of the introductions really quickly. For those that are home watching, I put some notes here. What our goal is for our next tests on Thursday, cohort A, which is in class right now. Their test next day is, of course, Thursday, October 1st, the next cycle. And cohort B, yours is on Friday, October the 2nd. Hopefully the same topics. Again, hopefully you find someone in both cohorts that might be available. But right now, as it stands, we're looking at the review of quadratics, all types, worksheets. And again, I can't remember the lesson number. I think it's lesson 1.10 or 11, 9, 10, or 11. One of those from the PowerPoint. So if you're following along at home with the PowerPoints, that's what we're going to be teaching. Just to preface right now, we're going to just go through some of the concepts so that everyone's okay. And I encourage you, ladies and gentlemen, when you're actually going through the examples, when you're going through your homework, and that's including the people here now in class, you have the sheets in front of you. Some already know this innately, but just have it with you when you're doing the work, right? So it's a good, kind of good summary sheet. And someone asked me also about today about the exam. Hey, this is also pretty good. Also, the PowerPoints are also pretty good, in my opinion. Okay. Without further ado, really quickly, I'm just going to read off. A lot of you realize in grade 11 we're talking about functions. And there's a definition, one more time. A function is a special type. For every x, there exists only one y value, right? And of course, what we've talked about, and you already have this in your handout, but I'll repeat it. You might have remembered that y equals ax squared plus bx plus c. That's the standard form of a quadratic, right? This is also known as the expanded form. So just make sure you're aware of that. Of course, you see beside you in your handout, ladies and gentlemen, in class, or if you're watching at home, there's another form, and that's factor form. Notice I'm using different letters that you were taught than in grade 10. So last day in the synchronous learning class, we use S's and T's because that's what was in your textbook. This package uses M's and N's. It doesn't really matter. A lot of you understand that. And the factor form tells us a lot of things. It tells us about the x-intercepts, right? And I'm going to use a semicolon if that's okay, even though they did it properly using and. Finally, so notice the relationship between the two. A lot of you know that's the whole point why we practice factoring and expanding algebra, so you can FOIL. So a lot of you already know that, right? That's what they hand in. There are some strengths between these two forms before we get to the third and final form. A lot of you realize that this c value of the quadratic, when we actually graph it, this is actually going to be the y-intercept. Notice that I'm not saying y-coordinate, I'm saying y-intercept, where it crosses the y-axis. And m and n here are first of views, right? So this is, oops, I should use different color. Talk about that in a moment. The one form that a lot of you relate and know is this one. And in grade 11, we're going to use P's and Q's. If you, again, you don't know who this gentleman is, but Dr. Chan would always teach us with P's and Q's. In fact, most schools teach with P's and Q's. In our old textbook in grade 10, I think we use H's and K's. So again, you're just getting adjusted to the format. And this is always called Vertex Form. Because Vertex Form and P and Q are the forms. And if you see from the top of the worksheet, and again, we talked about this last day, so review, most of the time when we graph the quadratic visually, and let's just see if I can do this. That's not so weird. Sorry, Maria. I decided to make a parabola that opens up. And a lot of you know that the y-intercept is right here. The two roots, or an x-intercept, are here and here. That could be m and n. And the vertex could be here. So I'm using 3 different colors. Hopefully you can capture that on the screen. And it's a little different from the handout. It might be slightly different. And they definitely denote it with the negative m's and n's and everything. Before we continue from class, everyone okay so far? This is obviously a lot of review, right, from grade 10. Speeding it up. Any questions here? Can I raise the chalkboard? Can I erase it?
Mhm.
So I've got to erase this. I'll leave that quadratic parabola up on there. So we talked about this already from the synchronous class. Oops, on the screen. That's okay. There. Back on there. When we're asking for solving, we're usually asking. And again, a lot of you notice from the PowerPoint, there are three kind of ways: factoring, using radicals. And this is one of the Vertex Forms. Or the Quadratic Formula. It might not be the exact order. So we're going to kind of do this slightly different. I've already done the lesson on factoring last day, so feel free to ask me questions if you have to. So we already did this one. So obviously today's class is kind of revisiting back these two. Some of you may or may not have done it that way with using the radicals. And don't get me wrong, some of you, if you're in class right now, notice rules of transformation. You may or may not have learned this in grade 10. So I'll talk about that very, very briefly. Let's talk about the quadratic formula. Had we had more time, or if you were in enriched grade 10 math, a lot of you realize that the quadratic formula is actually derived by completing the square of the standard form equation. Now, Mr. O did that, he did a good job. If he did not, then I don't know what to say. But basically, the quadratic formula is based on completing the square. So some of you, in fact, everyone here should know what completing the square is, but we'll do our refresher about to review that. And what is the quadratic formula? It is as follows. In standard form, we have the A, B, and C values. The way we articulate it is negative b plus or minus the square root of b squared minus 4ac all over 2a. Just as an aside to make it myself relevant, there was actually an interesting topic in the math circles. The math teacher, I think in the United States, he was talking about students should actually learn the quadratic formula a little differently because this is just group memorization. And I encourage it. The name at the time, I couldn't remember, it was Professor Lowe, I think? I can't remember exactly. But he talked about it another way. And don't get me wrong, it's really fascinating if you're that kind of math interested. And so I'll try to find out that video for you, just for enrichment if you want to know about the quadratic formula and this connection. But as it stands, a lot of you know how to use this. I'm not going to show you just yet the steps of completing the square though. I am going to talk about that last little part where it says rule of transformation. So hopefully at home, if you're not too sure where I'm looking, and I'll try to say this clearly, it's found on page 1, and just right on the right hand side, it says rule of transformation. So I'll write that over here. And honestly, ladies and gentlemen, in this grade 11 class, this is technically our third real unit, if we were going traditional. And so there's another way of kind of graphing parabolas, and it uses the concept called mapping technique. Now, some of you are slowly kind of understanding, we talked about mapping diagrams, where we divided the domains and range and drew the arrows. This is the kind of the cheap way, the interesting way, and I'm not trying to confuse you, ladies and gentlemen, but it actually is very efficient. Really, really quickly, it's an easy kind of rule, and you'll see me use this later, so don't panic if you don't like this, but you'll see when we take the worksheets up, the examples, it'll make sense. I apologize if I'm confusing, I don't mind repeating this again when I see you either again in class or synchronous. But the mapping technique is as follows, and notice what we're going to use. I'm going to use red to explain this, because the vertex form is as follows. One more time. It's P. Steve and I got this one up. So watch carefully what I'm going to do. Basically, it's an efficient way of showing. And I ran it over. It's supposed to be red. I like putting plus or minus because a lot of you realize the x value of the vertex, p, it could be plus or minus. So I like doing plus or minus there. And then technically it's supposed to be plus or minus p. And you'll see in a moment what we're talking about when we do it. Let's pause there. Let me show you what I'm talking about. Let's just say we have a point. Here's an example for this. Any point. Let's say we have 2, 3 that lies on the parabola, right? Sorry, so that's not right. Let's try 2, 4 that lies on the base parabola y equals x squared. And let's just say the quadratic in vertex form was y equals 2 x minus 1 squared plus 3. So some of you are already kind of connecting what this is. Some of you already know the shapes and what this parabola looks like. Let's see if it's on the screen. Yeah, good. So I'm just trying to illustrate what this mapping diagram does, right? So 2, 4, again, this is from the y equals x squared graph. Everyone agree? The parent. We talked about this last day. So doing some simple math to show how the mapping technique works, I think a lot of you know that this is my A, this is my P, and this is my Q. Again, you probably didn't do this in grade 10 enriched or anything like that in the regular class. It's just to show you how we can find the next transformed point without using a table of values or anything like that. Okay. And I think a lot of you know what I'm doing. So just to show our map here, the x coordinate is 2, right? Oh, it's 1. It's 1. No, it's 2. 2. Sorry, I'm stupid. And then the p value is going to be plus 1, right? Because we do the opposite. And the y coordinate is 4, so it's going to be multiplied by 2. And then it's going to add 3. So the new transformed point is going to be 3, 8 plus 3 is 11. So that's the new transform from 2, 4 to 3, 11. A lot of you know what I'm doing. I apologize, I'll move this over here really quickly so you can see it. Sorry, Maria.
It's okay.
To check, I'm just trying to show you this stupid thing. Let x equal 3, right? Everyone agree? That's what I'm trying. Let x equal let x equal 3. And hopefully this is going to work. When you plug this in into this equation, so 2 times 3 minus 1 squared plus 3, I get 2 squared plus 3. 2 squared is 4 times 2 is 8 equals 3, 11. So notice I didn't have to do it like an actual table to input. I just simply used the effects of A, P, and Q to find that new transformation. That's called mapping technique, and you'll see when we actually do it. Okay, I'll just stop this video right here.